Hello and welcome back to the Deep Dive. Today we are wading into some truly massive waters.
That might be an understatement.
Yeah, I think so.
Yeah.
We are talking about the universe, the cosmos, and the very specific, very strange set of rules that keep it all together. But more than that, we're tackling a tension that I think everyone listening has felt at some point.
hmm
You know, the idea that there's this unbridgeable canyon between science and faith.
It is a common narrative for sure. You have the laboratory on one side and the sanctuary on the other, and we are often told they are speaking two completely different languages.
Or worse, that they're at war.
Right, actively hostile to each other.
Exactly. The assumption is usually that science explains away the mystery, that the more we know about how the universe works, the less room there is for God. We assume that as our telescopes get better, our need for a creator gets smaller.
But the source material we're looking at today argues the exact opposite.
It really does. We are diving into a stack of research, and the main source is titled The Fingerprints of God, and it just flips that script entirely.
It's fascinating because the core thesis here doesn't rely on ancient philosophy or, just pure theology. It relies on modern data. It argues that modern scientific discovery, and we are talking about the cutting edge of cosmology, physics, and biochemistry, isn't pushing the idea of a creator away. Instead, it suggests that the deeper we look, from the vastness of the galaxies down to the microscopic structure of our own DNA, the more we find, evidence of intent.
Intent, that is the key word here, isn't it? We aren't just talking about a universe that exists. We are talking about a universe that looks suspiciously like it was built on purpose.
On purpose and with incredible precision.
So our mission today is to explore what scientists call the fine-tuned universe. We're going to look at the specific scientific anomalies that our source argues are, and I'm quoting here, impossible coincidences.
And we should probably stress that the word impossible isn't being used lightly here. It's not just hyperbole.
No, not at all. We are going to be looking at numbers and balances so precise that if they were off by just a hair's breadth, you and I wouldn't be here having this conversation.
Nothing would be here.
We've got a number coming up with 60 zeros after it
Yeah.
that apparently determines if stars can even exist.
We do. And we're also going to talk about the strange behavior of water that somehow saves all aquatic life on the planet.
And this idea I found really compelling, that Earth is basically the perfect classroom for observing the universe. It's a wild idea.
It is.
But I have to ask, before we really get into the weeds, is this just wishful thinking? Is this just people seeing faces in the clouds because they want to believe something is out there?
That's the skeptic's question, and it is a fair one. It's the first question you should ask.
Right.
But the source argues that when you start stacking these coincidences on top of each other,
Right.
one, then another, then a third, then a dozen, the cloud-gazing explanation starts to fall apart. The math just becomes too overwhelming to dismiss as pure chance.
Okay, well, let's unpack this. We need to start at the biggest possible scale, the macro scale. The source talks about the universe being on a razor's edge. What are we talking about here?
We are talking about the fundamental forces that hold reality together. And the big one, the one we experience every second of every day, is gravity.
Sure. Keeps my feet on the ground.
It does. We think of it as just the thing that makes an apple fall from a tree. But on a cosmic scale, gravity is the engine of star formation. It's the master sculptor of the universe.
Right. It pulls all that cosmic dust and gas together until it gets dense enough and hot enough to ignite into a sun. That seems straightforward enough.
It seems simple on the surface, but the calibration required to make that happen is, and I don't use this word lightly, mind-boggling. Gravity is actually incredibly weak compared to the other fundamental forces, like electromagnetism.
How weak are we talking?
I mean, think about it. You can pick up a paperclip with a tiny refrigerator magnet, right? That little magnet is overpowering the gravitational pull of the entire planet Earth.
Wow, okay. When you put it like that.
Yeah. But here is where it gets fascinating. The actual strength of gravity, the specific value of that force, is tuned to an almost incomprehensible degree of precision. Our source cites the work of physicist Martin Rees for this. He calculated that the force of gravity is fine-tuned to 1 part in 10 to the power of 60.
Okay, hold on. Stop there. 10 to the 60th power. I want to try and visualize that for a second. That is a 1 with 60 zeros behind it.
It is.
When I hear numbers like that, My brain just kind of shuts off. It sounds like white noise. It's meaningless. Can you make that make sense?
I can try. It's a number so large our brains really can't handle it intuitively. So let's try to build a visual. I want you to imagine a tape measure.
Okay, I've got a tape measure, like the one on my garage.
No, not a Home Depot tape measure. Let's imagine this tape measure stretches across the entire known universe.
The entire, okay.
From the moment of the Big Bang to the furthest edge of the dark, expanding void, we're talking billions and billions of light years across.
That is a lot of inches. A truly ridiculous number of inches.
Right. Now imagine that tape measure represents the entire possible range of strengths that gravity could have had. It could have been super strong over here or incredibly weak over there. The whole tape is the range of possibilities.
Well done.
Now on that tape measure, I want you to find the mark for the current strength of gravity, the exact setting that allows stars to burn and for us to exist.
Okay, it's one little tick mark on this universe-long tape.
Right. Now, if you were to move that mark by just 1 single inch,
1 inch across the whole universe.
1 inch, a change of 1 part in 10 to the 60th, if you moved it that tiny, imperceptible amount, the entire universe breaks.
Breaks how? Do we just float away? Is that what happens?
It is much more catastrophic than that. Let's say you make gravity slightly stronger, just that 1 inch on our cosmic scale. The pull would be so immense that when stars form, they don't just burn, they collapse.
To crush themselves.
They crush themselves under their own weight. They would burn through their nuclear fuel in a geological flash. Life, especially complex life, would never have time to evolve or develop because the universe's main energy source would die out before biology could even get started.
Okay, so stronger is bad. We get a quick, bright fireworks show, and then eternal darkness. What if we crank it the other way? What if we make gravity weaker by 1 inch?
Then nothing happens. Ever.
What do you mean, nothing?
I mean, if gravity were just that tiny bit weaker, the clouds of gas and dust in the early universe would never have pulled together tightly enough to ignite nuclear fusion.
So no stars.
No stars, no suns, no
Wow.
planets, no galaxies, just a cold, dark, endlessly expanding soup of hydrogen and helium.
So in either scenario, you get a dead universe. It's
Yeah.
either a flash in the pan or it's
Yeah.
just nothing.
Exactly. And that is why the source calls this a fingerprint. The fact that gravity is dialed into this exact razor-thin specific value where it is strong enough to form stars but weak enough to let them burn steadily for billions and billions of years is, from a purely statistical point of view, absurd.
But wait, let me play devil's advocate here for a minute. Isn't this just a classic case of survivorship bias?
Explain.
Well, we are here to measure gravity. So obviously, gravity has to be set to the value that allows us to be here. If it was wrong, we wouldn't be here to complain about it. Maybe there are a trillion other universes out there that failed, and we just happened to win the cosmic lottery.
That is the multiverse argument. And you're right, it is the most common scientific counter-argument to fine-tuning.
So what does this source say about that?
Well, it points out something really important. The multiverse, as a concept, is a philosophical or a mathematical hypothesis. It's not observational science.
Meaning we can't see these other universes.
We have zero observational evidence for a multiverse. It is essentially an idea designed specifically to explain away the incredible precision of this universe. The source argues that believing in an infinite number of invisible, unobservable, untestable universes, well, it requires just as much faith as believing in a creator.
So you either have faith in a trillion invisible universes or faith in one designer.
At a certain point, yes, that's the choice it boils down to. You have to explain the precision somehow. And gravity isn't even the only one. This is just the first dial we're looking at. The source introduces this whole concept of cosmic constants.
Yeah, I saw that list in the notes. These are like the factory settings of the universe, right?
That is a great analogy. These are unchanging numbers that are just baked into the very fabric of reality. They seem to be fundamental.
And the list includes things like the speed of light.
The speed of light, the Planck constant, the gravitational constant we just talked about, and something called the cosmological constant, which has to do with dark energy and the expansion of the universe.
And the proton to electron mass ratio. That one always sounds super technical, but I gather it's just as crucial.
It is absolutely crucial. These aren't just a random collection of numbers. They are all interconnected values. And the argument here is the engineered nature of these numbers. The source uses this analogy. If you were to walk into a massive recording studio and you see a giant soundboard with 1,000 different dials and sliders,
Go.
and every single one of those 1,000 dials was set to the exact perfect millimeter to produce a beautiful, complex symphony, You wouldn't just assume the wind blew through the window and set them all perfectly.
No, you'd assume an audio engineer spent a long time setting them up.
Right, because you know that if you just nudge one of those dials, the speed of light dial just a fraction, or the electromagnetic force dial just a notch, you don't just get a different kind of song.
You get static.
Noise.
You get noise or silence.
Right.
You get a universe where chemistry is impossible, a universe where atoms wouldn't even hold together, or a universe that would expand so fast that matter would just rip itself apart before it could ever form a star. So the source equates these physical laws to, well, to God's laws. It's a theological argument based on the physics.
Yes, it actually references a passage from the New Testament, Hebrews 1.3, which speaks of God sustaining all things by his powerful word. The idea here is that these constants aren't just mechanical, arbitrary facts about the universe. They are the active mechanism by which the Creator sustains the ongoing possibility of life. It's a very active, continuous view of physics.
That's a huge shift in perspective. It's not God lit the fuse and walked away. It's more like God is holding the dials in place right now.
That's a good way of putting it.
But speaking of lighting the fuse, we have to talk about the origin story itself. The source makes a really interesting point about the history of science on this.
This is one of my favorite parts of the research because it really highlights how much the scientific consensus can shift over time. It's not a fixed monolith.
Yeah, because for a long time, the smart scientific take was that the universe was eternal, right? That it had just always been here.
That was the dominant view, absolutely. Up until the mid-20th century, the leading theory was the steady state theory. The idea was that the universe didn't need a creator because it didn't have a beginning. It just was. It was static, eternal, unchanging. And that was a very comfortable position for a purely secular science.
Because if it's eternal, it doesn't need a cause. It just is.
Precisely. An eternal universe doesn't require a Genesis 1. But then, in the 1920s and onwards, things started to get really uncomfortable for that view.
This is where Hubble comes in.
This is Hubble. Edwin Hubble discovers that the galaxies are all flying away from us. The universe is expanding. Then, later, we discover the cosmic microwave background radiation, which is basically the leftover heat, the afterglow, from a massive explosion.
Smoking gun.
Exactly. The evidence became overwhelming. All the math, all the observations started pointing backward to a single moment in time, a singularity. A moment where all time, all space, and all matter exploded into existence out of nothing.
And the scientific community.
Yeah.
They loved this new idea.
Oh, they hated it. Some of them absolutely hated it. You have to remember, the term Big Bang was actually coined by an astronomer named Fred Hoyle, a staunch atheist and proponent of the steady-state theory, and he meant it as an insult.
Wait, really? I always thought Big Bang was just the official technical term.
Nope. He was being sarcastic on a radio show. He was mocking the idea because he thought it sounded way too much like religion being smuggled into science. He essentially said something like, "What, are you telling me there was some Big Bang?" And the name just stuck.
That is deeply, deeply ironic.
It is, because the data eventually forced their hand. The evidence was just too strong. They had to admit, however reluctantly, that the universe had a start date. And the source makes a huge point of this. Science, through its own methods, eventually caught up to the very first sentence of the Bible, in the beginning.
So the argument here is that the physical evidence demands a cause that is outside of nature.
Yes, that's the logical conclusion. If nature itself had a beginning, then the thing that caused it to begin cannot, by definition, be a part of nature. It has to be supernatural.
Okay, so we have this macro universe that's perfectly turned for life to even be a possibility. The laws are right. The origin happened, but that's just the big picture. We need to zoom in now, because even if the universe works, that doesn't guarantee that we should be here.
And that is the next layer of the argument. It's one thing to have a universe with stars. It's another thing entirely to have a very specific stage for the drama of life to unfold. The source calls this the Goldilocks scenario.
Part 2, the planetary stage. And it's all about location, location, location.
It really is about cosmic real estate. The source focuses heavily on something called the habitable zone. You might have heard it called the Goldilocks Zone, the region around a star that's not too hot, not too cold, but just right.
Right. And Earth is parked right in the middle of the VIP section.
But it's not just about being warm enough. It's incredibly specific. If Earth were just 5% closer to the sun like our neighbor Venus, our oceans would boil away into the atmosphere.
A runaway greenhouse effect.
A runaway greenhouse effect. An absolute inferno, with surface temperatures hot enough to melt lead. Unlivable.
And if we were just a little farther away, like Mars.
The oceans freeze solid, You get a frozen, barren wasteland. The key here, the absolute non-negotiable for life as we know it, is liquid water. And Earth is positioned at the exact orbital distance required to maintain vast oceans of liquid water for billions and billions of years.
But hold on, isn't it true that scientists are finding Goldilocks planets all over the galaxy now? I feel like I read a headline every week about a new Earth-like planet they've discovered.
That is true. We are finding more and more planets in that orbital zone. But the source argues that being in the zone is just the first ticket you need to get into the stadium. There are dozens of other factors required to actually play the game.
Okay, so what else?
For example, the tilt.
The tilt. You mean the fact that Earth is kind of crooked on its axis?
Yes. Earth spins on an axis that is tilted at exactly 23.5 degrees relative to our orbit around the sun.
And that's what gives us seasons. Summer, winter, spring, fall.
Exactly. But the source argues it does much, much more than just give us pumpkin spice latte season in the fall. This tilt is a critical global temperature regulation system. It distributes the sun's energy much more evenly across the surface of the planet throughout the year.
What would happen if we didn't have that tilt? Say we were just straight up and down 0 degrees.
If we had no tilt, the poles would be eternally, bitterly frozen. The ice caps would be enormous, and the equator would be an unlivably scorching desert belt year-round. The temperature gradient between the two would be extreme. Widespread agriculture would be incredibly difficult, maybe impossible.
And what if the tilt was too extreme? Like if we were tipped over on our side, like Uranus is?
Then you would have catastrophic seasons. Half the planet would be in total darkness and deep freeze for months at a time, and the other half would be baking under a relentless, unmoving sun. The 23.5-degree tilt is a sweet spot that allows for a diverse, stable, global biosphere. The source interprets this as an act of loving foresight. It even references Psalm 19, the heavens declare the glory of God.
Speaking of stability, let's talk about our neighbor, the moon. Because I think most people, myself included, usually just think of the moon as a pretty nightlight.
The moon is an absolute anomaly in our solar system. It's a total weirdo.
In what way? I mean, lots of planets have moons. Jupiter has like 80 of them or something.
True, but look at the size ratio. Our moon is unusually, enormously large compared to the size of Earth. Most moons are tiny pebbles, cosmic gravel, compared to their host planets. Ours is about a quarter the diameter of Earth. That's huge. And that size isn't just for decoration, it serves a critical utility.
It's a stabilizer. Right. That's what I've heard.
Think of it like a massive gyroscope or the stabilizer fins on a giant cruise ship. Because the moon is so big and relatively close, its gravitational pull locks Earth's rotation in place. It prevents our planet from wobbling chaotically on its axis.
So our stable 23.5-degree tilt would be fluctuating all over the place without the moon.
All over the place. We could swing wildly from 0 degrees to maybe 80 or 90 degrees over long periods. The climate chaos would be catastrophic. One epoch, you have no seasons. The next, you have the most extreme seasons imaginable. Any complex life trying to survive that, it's very hard to imagine. The moon keeps us steady.
And of course, it drives the tides, which circulates nutrients and oxygenates the oceans. But here's the thing that always gets me, and the source makes a big deal of this, because it is just so weirdly specific, the eclipse coincidence.
Ah, yes. It is a striking visual miracle, as the source puts it. It's almost theatrical.
So break it down. The sun is approximately 400 times larger than the moon in diameter.
A monster compared to the moon. A monster. But by a stunning coincidence, the sun is also approximately 400 times farther away from Earth than the moon is.
So to us, standing here on the surface of Earth, they appear to be exactly the same size in the sky.
Which is why, during a total solar eclipse, the moon fits perfectly over the face of the sun. It doesn't just block it out loosely, it covers the disk so precisely that it allows us to see the sun's corona, its ethereal outer atmosphere.
Is there any physical reason for that? Like, does the moon have to be at that precise distance to stabilize our tilt?
Not that we know of, no. It could be a little closer, a little farther away, and still do its main gravitational job just fine. The fact that the geometry aligns so perfectly for a ground-based observer, the source frames it as an Easter egg, a little signature left in the sky by the artist.
I love that image.
Yeah.
It doesn't help us survive, but it creates beauty and invites discovery.
Exactly.
Okay, so we have the universe set up, the laws are right, we have the planet set up, it's stable and in the right place. Now we need to actually build life. And this brings us to part 3, the microscale.
This is where we get into the nitty-gritty of chemistry and biology. And we have to start with water again. We mentioned that its position allows it to be liquid, but the water molecule itself has a bizarre physical property that breaks the rules of almost every other substance in the universe.
This is where it gets really strange.
It does. Think about any other substance, a candle, for instance. If you melt wax and then let it cool and freeze, the solid wax sinks to the bottom of the liquid wax, right?
Right. Because solids are denser than liquids. That's high school physics. The molecules pack together tighter when they get cold.
Usually. That is the rule for almost everything. But water is the great exception. Water expands when it freezes. It becomes less dense as a solid than it is as a liquid. That is why ice cubes float in your drink.
Which seems like a minor convenience for my iced tea. But why does that matter on a planetary scale?
It matters for everything living in water. If ice sank, if water behaved like a normal liquid, think about a lake or an ocean in the winter. The ice would form on the top surface, sink to the bottom, and then the next layer would freeze and sink, and it would pile up.
The lake would freeze solid from the bottom up.
It would become a solid block of ice. It would kill every fish, every plant, every single thing in it, every single winter. The oceans would be largely lifeless.
But because ice floats.
Because ice floats, it forms a protective shield on the surface. It insulates the liquid water below from the cold air above. It keeps the water underneath warm enough for all of aquatic life to survive the winter. The source argues this specific, anomalous physical property is an unambiguous design feature intended to preserve life.
It's like the water molecule was custom built with a planetary scale safety feature.
It looks that way. And the atmosphere has a similar story. We have this very specific recipe, roughly 78% nitrogen, 21% oxygen, and some trace gases.
And that 21% oxygen is the magic number.
It is the balance point on a razor's edge. If oxygen levels were just a little bit higher, say 25% or 30%, the atmosphere would become incredibly volatile. The smallest spark from a lightning strike could set off uncontrollable firestorms.
Wet forests would burn?
Wet forests would burn. We couldn't control combustion. It would be a world of constant raging fires.
Okay, but what if it were lower? Say 15%.
Then large, complex, air-breathing animals like us couldn't exist. We wouldn't be able to get enough oxygen to power our large brains and our muscles. We would suffocate. So the atmosphere is balanced precisely on this knife edge between uncontrollable global fire and suffocation for complex life.
And keeping that balance involves the electromagnetic force too, right? It all ties back.
It does. The source ties this back into the fundamental forces. If the electromagnetic force were slightly stronger or weaker, atoms wouldn't bond correctly to form the molecules we need. You wouldn't get the stable chemical reactions required for respiration in the first place. Again, it's all connected in this intricate web.
But the ultimate micro argument in this source, the one that feels like the centerpiece, has to be DNA.
Yes, the code. The language of life.
I think most of us have a basic idea that DNA is important, but the Force describes it as a literal language. And I want to push on that. Are we being poetic here? Is there just an analogy? Or is it literal?
That is a crucial distinction. And the source argues it is not a metaphor. It is a digital four-character-based encoding of complex information that functions exactly like a piece of computer software. You have an alphabet of 4 chemical letters, A, C, G, and T, and the specific sequential arrangement of those characters conveys precise instructions.
But here's the devil's advocate question again. We see patterns in nature all the time. Snowflakes have beautiful, intricate patterns. Crystals have patterns. Is DNA just a really, really complicated snowflake?
That is a million-dollar question. And the source's answer is an emphatic no. And here's why. There's a fundamental difference between order and information.
Unpack that for me.
Okay. A crystal of salt is highly ordered. The atoms line up in a very simple repeating pattern. NaCl, 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 over and over again. It's repetitive, it's simple, it's determined by the basic laws of chemistry.
Okay, simple and repetitive.
DNA is not repetitive like that. It's specific. It's a periodic, meaning it doesn't repeat in a simple way. It conveys a message. Think of it like this. If I type the letters A, B, C, D over and over again for 1,000 pages, that's order. That's a crystal. But if I write the opening chapter of Moby Dick, that is information.
One is just a simple pattern. The other is a story with meaning and instructions.
Exactly. And specified complex information in our uniform and repeated experience always, 100% of the time, comes from a mind, from an intelligent source. You can have billions of years of wind and rain blowing through a canyon, and it might create a cool, ordered shape. It will never, ever carve the Gettysburg Address into the rock face.
Because the wind doesn't have intent. It doesn't know what the Gettysburg Address is.
And that is the slam dunk for the source. The DNA in a single human cell contains billions of lines of distinct, non-repetitive functional code. It is a detailed instruction manual for building a human being, or a tree, or a bacterium.
Fearfully and wondrously made.
That's the biblical phrase the source points to, yes. The staggering complexity of that biological software, it argues, simply refutes the idea of randomness. When we look at DNA, the source claims we are reading a message from the Creator. To assume that blind, undirected processes of time and chance wrote that software is, well, it's a leap of faith that is arguably much larger than believing in a programmer.
So we've covered gravity, the planet, the water, the DNA. That's a lot. But there's one more major point the source makes that I found really unique. It's what they call the privileged planet argument. And this one felt different from all the others.
This is the meta argument. And I agree, I find this one particularly profound because it moves beyond the question of mere survival. The argument here is that Earth isn't just optimized for life to survive. It is also perfectly optimized for life to make discoveries, for observation.
Yeah, explain that. Because usually the whole conversation is just about surviving. But this is about seeing.
Think about our atmosphere. It's transparent to visible light. That seems normal to us. It's all we've ever known. But many planets in our solar system have thick, opaque atmospheres. Think of the swirling, dense clouds of Jupiter, or the permanent orange haze of Saturn's moon, Titan.
So if we lived there, we'd never see the stars.
You would never see the stars. You would never know there was a universe beyond your own cloud tops. You would be living inside a planetary fog bank. You couldn't practice astronomy.
But because our atmosphere is clear.
We can build telescopes and see the cosmos. We can measure the cosmic background radiation that told us about the Big Bang. We can witness that perfect solar eclipse we talked about, which was actually used as evidence to help prove Einstein's theory of relativity. The very conditions that make our planet habitable also make it the perfect platform for scientific discovery.
So the argument is that we were placed here in this specific spot with this specific setup so that we could discover the rest of it.
The universe feels like a classroom. That's the imagery the source uses. The suggestion is that God didn't just put us here to eat, sleep, and reproduce. He put us here to look up, to measure, to understand. The setting itself seems designed to invite exploration and reveal its own secrets.
Wow. That really changes the vibe of the whole thing, doesn't it? It's not just, you were incredibly lucky to be alive. It's, I built this place for you, and I want you to see what I made.
It creates the potential for a relationship between the observer and the designer. It suggests that the act of science itself, the act of discovery, is not something that threatens faith, but is something God actually intended for us to do from the beginning.
So, where does this all leave us? If we take all these pieces together, the gravity, the moon, the tilt, the water, the DNA, the clear skies, where do we land? What's the final conclusion?
The source lands on a powerful idea, science as an act of worship.
I like that phrase. But unpack it. What does that mean in practice?
It's the idea that science and faith are not two separate realms, but two different tools for looking at the same reality. Science is brilliant at answering the what and the how questions. What is the atom made of? How does photosynthesis work?
Right. The mechanics of it all.
But Scripture and faith are about revealing the who and the why. And the argument is that they don't have to fight.
They're not in competition.
Not at all. In fact, the source argues they are profoundly harmonious. When a biologist discovers a new, incredible layer of complexity in the cell, they aren't debunking God. They're uncovering another layer of his genius, his craftsmanship. That discovery shouldn't lead to skepticism. It should lead to awe. It should lead to worship.
It's like analyzing a masterpiece painting. Knowing the chemical composition of the red paint doesn't make the artist less real or the painting less beautiful.
It makes you appreciate their technique even more. That's a perfect analogy. And that brings us to the final personal connection. Because we can talk about galaxies and gravity constants all day long, but the source material really wants to pivot this entire cosmic discussion down to the listener, to you.
Yeah. It emphasizes that this fine-tuner, this cosmic architect, isn't just some abstract, distant force. It's personal.
If the universe is this precise, beautiful house built with such extreme care and foresight, it strongly implies it was built for someone.
And that someone is us.
Yeah.
Individually.
The core message is this. You are not an accident. You are not just a random collection of atoms that happen to bump into each other in a cold, meaningless universe. The same mind-boggling precision that went into setting the gravity constant also went into the design of you.
That's a heavy thought. In a good way. It connects the physical order of the entire universe to the spiritual value of the person listening right now.
And it extends an invitation. The source closes by reminding us that the same God who calibrated the stars is the God who invites us into a personal relationship through Jesus Christ. It's a call to recognize that we are known and we are loved by the architect of it all.
It really reframes everything.
Hmm.
How you look at the night sky, and maybe even how you look in the mirror.
It does. It changes everything.
I want to leave you, our listener, with one final thought to chew on from all this. We talked about the universe being a house built for us. If that's true, if the math and the physics of the universe really do prove it wasn't an accident, then what does that imply about the purpose of your own life? If the stage was set with such profound intention, maybe the play you're acting out has far more meaning than you realized.
That is the ultimate question.
Thanks for diving deep with us today.
It was a pleasure.
We'll see you next time.